For billions of years, light has been the universe's storyteller. It's crossed unimaginable distances, carrying tales of newborn stars and dying galaxies. Light is the witness to everything that has ever happened. But what happens when the story ends? What becomes of light when time itself runs out? Does it survive, or does it fade into eternal darkness? Let's explore the ultimate fate of the last photon. At first glance, it seems like light should be immortal. A photon, the fundamental particle of light, doesn't experience time. From its perspective, the journey from a distant star to your eye is instantaneous. It doesn't age. It doesn't decay. So, it should last forever, right? Well, it's not that simple. While light doesn't age, it absolutely needs time to exist. Think about it. Light is defined by its movement, its journey through space. Its very existence is a process, a continuous propagation of electromagnetic waves. Without time, there's no before and after, there's no movement. A photon can't travel from point A to point B if there's no duration for the trip. So, in a universe where time has stopped, light as we know it simply cannot be. It's a traveler without a road. But before we even get to the end of time, the universe has a long, slow journey ahead. And it's a journey of expansion. Ever since the Big Bang, the fabric of space-time has been stretching, pulling everything further and further apart. This cosmic expansion has a profound effect on light. Imagine drawing a wave on a rubber sheet and then stretching the sheet. The wave gets longer, right? The same thing happens to light. As photons travel through expanding space, their own wavelengths get stretched. We call this phenomenon redshift. The light from distant galaxies appears redder to us because its wavelengths have been stretched out on its long journey across the cosmos. This stretching isn't just a visual effect. It's a fundamental change to the light itself. And this change is crucial because a photon's energy is directly tied to its wavelength. Shorter wavelengths, like blue or ultraviolet light, carry more energy. Longer wavelengths, like red or infrared light, carry less. So, as the universe expands and stretches the light within it, every single photon is slowly, inexorably losing energy. The light isn't disappearing, but it's getting weaker. It's cooling down. The brilliant, energetic light from the early universe is gradually shifting into a faint, low-energy glow. This is the slow, cold fate awaiting every ray of light. It won't vanish in a flash. It will simply fade, becoming ever more tired and stretched out over trillions and trillions of years. Now, let's fast forward to the unimaginably distant future. We enter what scientists call the heat-death era of the universe. By this point, all the stars have burned out. The brilliant stellar furnaces that once lit up the cosmos have all gone dark, leaving behind only cold remnants like black dwarfs and neutron stars. The vibrant, swirling galaxies we see today have faded into ghostly collections of dead objects. No new light is being created. The universe is running out of fuel. The only light left is the ancient light, the photons that have been traveling since the age of stars. These old, tired photons are all that remains of the universe's bright and glorious past, relics of a bygone era, endlessly stretched and weakened by cosmic expansion. As time marches on, these last photons become increasingly ghostly. The relentless expansion of space continues to stretch their wavelengths to absurd lengths. A photon that started as visible light might eventually have a wavelength larger than an entire galaxy. Its energy will become so minuscule, so close to absolute zero, that it will be practically indistinguishable from the background quantum noise of empty space. Imagine trying to detect a ripple in an ocean during a hurricane. It's just lost in the chaos. The light will still technically exist, but it will be so faint and so stretched that it will be completely unobservable. For all practical purposes, the universe will be dark, not just dark like a moonless night, but a profound, absolute darkness where the very concept of seeing has lost its meaning. What happens if time itself stops? This is a deep, philosophical question, but in physics, time is linked to change. If everything in the universe reaches a final, static, unchanging state, the ultimate equilibrium. Then time, as a measure of change, effectively ceases to exist. In this frozen reality, what happens to our last, impossibly stretched photons? Without time, there is no motion, no interactions, no observers. A photon can't travel, it can't be absorbed, it can't be measured. It becomes a frozen artifact in a static museum. In a universe without change, light has no function, no purpose, no meaning. It's a silent note in a song that will never be played again. The very concept of light is tied to the dynamic, evolving nature of our universe. Without time, it loses its identity. So, is there any hope? Could light somehow survive forever? Some speculative theories offer a glimmer. For instance, the strange world of quantum mechanics suggests that even in a seemingly empty vacuum, tiny quantum fluctuations can persist. Perhaps these fluctuations could create new, tiny pockets of energy, or even spawn new baby universes where the laws of physics are set. In such a scenario, light might find a new cosmos to illuminate, a new path to travel. But these are just ideas on the very edge of our understanding. For our universe, the one we know and live in, the outlook is bleak. The laws of thermodynamics point toward a one-way street ending in a cold, dark, and static state. The final chapter seems to be already written. Picture it, a universe without light. Not a single star in the sky, no gentle glow from a distant nebula, no shadows, because there's nothing to cast them. Just a uniform, featureless, and eternal darkness. The temperature is a fraction of a degree above absolute zero. Everywhere, space stretches on infinitely, but it's all the same, an endless, silent, and unchanging void. This is the ultimate fate that awaits our cosmos, a quiet, dark, and lonely place where the memory of light has long since faded. It's a sobering thought, a universe stripped of its most defining feature. For its entire existence, light defined the universe. It was the first thing to be set free after the Big Bang. It guided the formation of stars and planets. It was the energy source that sparked life on our own world. Light is woven into the very fabric of reality. But in the grand, cosmic endgame, even light must let go. The journey that began with a brilliant flash must end in absolute silence. And when the last, most stretched out photon finally fades into the background noise, becoming indistinguishable from nothingness, the universe, at last, falls completely and utterly silent. Thank you for joining me on this journey to the end of everything. If you find these cosmic questions as fascinating as I do, make sure to subscribe and hit that bell so you don't miss our next exploration into the mysteries of the universe.